Okay, we're looking at version 4 of the sample problem bank for the upcoming test, major quiz test. Test 1. Sample problem bank has been sent out. So we're looking at, again, version 4. Okay, version 4, you're asked to construct the graph of a reciprocal shape. Okay, now, before we consider any of the parameters, and I've got them listed here, we'll see how they work. We're going to construct a graph of the reciprocal shape. We're not going to label it yet because we'll do that after we get the specifics. Okay, so we do a 4x4 rectangle. And we put the red dot at the center for the reciprocal shape. And then we immediately draw a horizontal line and a vertical line through the red dot. Now, to construct the reciprocal shape, we draw a vertical line halfway between the right edge and the center line, and halfway between the left edge and the center line. Everything's nice and symmetric. And then we draw a vertical line halfway between each of those lines and the center line. I'm going to extend those lines a little further so I can label them. And of course, that's what we're going to do as soon as we figure out where the red dot is. So this is a 4x4. I call it a rectangle because in general, we're going to be graphing these functions in rectangles. Okay, well, that takes care of the vertical lines. Notice that these 4 lines here are twice as close as these lines here. The last line, the last construction line to the right and the right boundary. And similarly on the left. This is because we go halfway and then we go half of that way. Okay. Also gonna, since I'm doing vertical lines, I'm gonna do vertical lines to the boundary. Now I've got room to label these lines above or below the axis or below. Okay, well then we do horizontal lines. Already got the horizontal center line. Well, the rule is exactly the same in that we go from each edge halfway to the center line. Each horizontal edge halfway to the center line, and we get this. And you can do it better than I can. I'm not being particularly careful. I think my red dot's a little bit too low. That's not going to make a huge difference. Okay, so we have these 2 horizontal lines, and then we take, for each of these, we go twice as close to the center again. So we're dividing toward the center, unlike with the horizontal lines for the squared exponential functions, where our horizontal lines go halfway to the lower edge, and that gives us the center line. The center line is halfway to the lower edge. Then we go halfway from there to the lower edge, and halfway from there to the lower edge, and halfway from there to the lower edge, as many times as we need to construct a function to follow the rule for the function. Okay, now I'm not going to write out these rules. I've already done it. If you can't find it, tell me what you think the rule is, email me or whatever, and I'll correct you if necessary. Tell me what you think the rule is, because I'm going to tell you right now, and you could write it down. Okay, we start at the left edge, 1 construction line below the center, and we make a marker. Move over 1, down 1. We move over 1, down 1. And if we tried to move over 1, we wouldn't have any place to go down unless we had more grid lines below. So that's it within this rectangle. Then we start on the upper edge, 1 vertical line to the right of the center line, vertical center line. And we go over 1, down 1, over 1, down 1, until we hit the edge of the rectangle or the square. And we're done. And then we go ahead and construct a curve here to here and from here to here. We don't connect this point to this point because that would violate the rule. Over one, down one, over one, down one. If we have more lines, we could go over one, down one. We'd have to go down twice as far because every time we come down twice as far, but you don't need to know that right now. We'll talk about that later. This continues going on down, creates what you call an asymptote with the vertical line, the vertical center line. Over here, same thing. We don't try to connect this point to this point. We just take this much. We'll extend it later. It's easy to extend, and you've already seen the formulas for these functions. You know what the graphs look like. So this is part of the entire graph, which is defined for all values of x other than whatever the value is at the center line, because we never reach the center line with these rules. And we never reach the center line when we plug numbers in to the definition of these functions, because if we do, we get a division by zero, which is undefined. It's a good indication we've got an asymptote. Well, that's all aside. You don't have to know that, but you make note of a few of those things. Some of you know a little bit more than I'm asking. That might cover some minor error you make at some point. Okay, so it's worth doing. You have unlimited time. Now, I don't recommend that you take a lot of such notes until you are pretty sure you're going to be able to finish the test. There are only going to be 6 problems. Okay. And 2 of them will be like this. This is for the reciprocal function. The other 2 are for the exponential and squared function. You're going to get 2 of those. All right. Now, what do we do with this? This is construction of the reciprocal shape. Okay. So, having done the reciprocal shape, we take the information, and you can read this because you have a copy of versions 1 through 4. Okay, 16, negative 12. Where's that in your instructions? Well, that's the location of the red dot. So the red dot is at x equals 16, y equals negative 12, which means, we could label it here inside the rectangle, but it gets a little crowded. And I really am liking it better and better if we just label this thing. By labeling the line. Some point on the line, because at every point on this line, it's the same. Make sure you understand that. Understand why, make sure it's just obvious so you can pass it. And of course, y equals negative 12 on this center line. Now, just for a little emphasis, you don't need to do this. So we can keep track of where the center line is, because there are a lot of lines. I kind of blue shade this line. Yeah, this is vertical horizontal line through the red dot. Okay. Well, now, next thing we want to do is we want to label all the construction lines and the boundary lines. Well, if x equals 16 and this is 4 by 4, then this is 2 units and this is 2 units. Now, 2 units to the right of x equals 16 is x equals 18. And 2 units to the left is x equals 14. I've seen some instances where people put the 18 here and the 14 here in the standard, and we're going to stick to the standard orientation of the x and y axes. The x-axis is to the right and the y-axis is up. If the x-axis is to the right, this number has to be bigger than this number, which has to be bigger than this number. Okay, well, we can label 2 more lines. Let's label these 2. And maybe label the last line up here. So this line is halfway from the left edge to the center. Well, halfway from 14 to 16, everybody, I think, understands that that's 15. And then halfway between the right edge and the center is this line, because that's where we constructed it. That's going to be x equals 17. And then halfway between this line, the x equals, and I did label x. We really want to label x. That's just the number. We want to remind ourselves that this is the x coordinate. It's this stage. It's really easy to get. As a matter of fact, at this stage in my life, after having done this for about 100 years, it's still easy to get confused. Maybe the 100 years has something to do with that. I don't know. So here's x equals 15, x equals 17. Up here, we want to label this. It's halfway between 15 and 16, which is 15 and a half. I kind of prefer fractions to decimals because fractions can be equal to decimals. When you have fractions, especially halves, I think it's kind of important to understand that's what you have, not 0.5s. If you got thirds, well, a third isn't exactly 0.33, the threes keep going on. So, exact label. Now, I haven't left myself a lot of room to label this line, but I'll squeeze it in. And that's this line here. With an arrow there. Maybe a little bit hard to read. Make a bigger picture than I have and label it as clearly as you can. As we did on the first day when everybody did this correctly. And on the second day when everybody came in and took the quiz and there was only maybe one person that had 1 point wrong on one of the graphs. You need to be there with this. You were, everybody was, including half the class that's disappeared since then. Okay. It's a manageable task. Just make sure you spend the time and make sure you know how to do these and retain that throughout the rest of the course, because it's always going to be important. Well, now we label the horizontal lines. No, we don't have yet a horizontal line. Boundaries for each of them. Boundaries, but there we go. And this one, well, y is negative 12 here, and it's 2 units up here. You go 2 units up from negative 12, well, that's 2 units in the positive direction. If your temperature is 12 degrees below zero and you increase it by 2, you get 10 degrees below zero. If you're $12 in the hole and you get $2, now you're only $10 in the hole. Plenty of ways to understand that it's not negative 14 here, it's negative 10. Okay, and then down here you have y equals negative 14. Then it's easy to label the other lines. If you understand that this line is halfway between these two, or halfway between negative 14 and negative 12, it's negative 13. And this line is halfway between here. That's the way you constructed it if you follow the rules. And this line is y equals negative 11. I had negative 11 in my mind to write it. And I said, wait a minute, that's not negative 11. I don't know why, I just some circuit in my brain flashed and I started to write negative 9. So you see how easy it is to do. You want to think. Write it down, but think about it, make sure you've written it correctly. Okay. That might be more important for me than it is for you, I don't know. But I think it's important for everybody. You always want to check yourself. We had like 4 inches of rain yesterday and over an inch, 4 inches of rain overnight, and yesterday we had well over an inch. So I don't know that I have any arthritis there, but something doesn't feel right. Okay, and the hurricane hasn't even gotten here. This is very interesting. We're closed today, as everybody knows, and I was a little surprised because there's no serious flooding. Rain has been very steady, so it's drained off nicely everywhere around town. There's one place we probably had probably backed up, but and there's a creek that runs through my backyard. Usually it floods like crazy. You can get up every rain. Rain has been so steady; it's just been running full but not overflowing all night. I think. See any evidence of flooding? Well, that's a digression. Okay. Now back to here, we want to label this line And something figure feels okay this time. Okay, between -12 and -13, well, this line's halfway between, because that's the way we constructed it. This is y equals -12 and a half. This line is y equals -11 and a half, halfway between -11 and -12. Now we've got all the lines labeled. Okay, now I ask that you do this, label all the lines, all the construction lines and boundary lines, and then make a table of these coordinates. So your table. Very simple. You've heard me say this a bunch of times. Really, you're probably going to completely understand it when I say it, but if you don't, ponder it and come back and think about it until you do. Coordinates of this line are where the vertical line meets the horizontal line. X equals 14, y equals -12 and a half. So it's at 14, -12 and a half. And this point, well, the line x equals 15 intersects this line, which is y equals 13. So that's 15, -13. And then this line, let's see, what is this line? We have to go up here to see it, but it's 15 and a half. That's 15 and a half. And y is, oh, you're on the lower boundary. We've already labeled that. That's -14. So you don't have to do a whole lot of thinking to label the coordinates of these points if you've done everything correctly. And the essence here is to do everything correctly. If you're doing this long enough, then I'm not going to be very lenient on grading when I see errors. Okay. Now this point is on the x equals 16 and a half line and on the y equals -10 line. This point is on the y equals -11. Well, let's do it. X equals 17, y equals -11. And this point is on the x equals the x equals 18. Okay. This point is on the x equals 18 line. And the y equals -11 and a half line. Okay, there's our table. And might even label this. Structure points. Okay, now we're going to do things with this. We're going to solve g of x equals -13.3. Solve the equation g of x equals -13.3. And this solution is so wonderful, it deserves its own color. Okay, so what is -13.3? Well, g of x is the y coordinate of the function. So you can even write it as y equals g of x. I didn't, but you can always set y equal to the function if that's what you're graphing. This is the function g of x, meaning that g of x values are on the vertical axis. Coordinates of g of x correspond to horizontal lines, which give you y coordinates. And our y coordinates there go from -14 to -10. So we want to solve y equals g of x equals -13.3. But where's -13.3? Here's y equals -13, and -13.3 is between -13 and -14. So about a third of the way from -13 to -14. So I'm not sure I've got it exactly right. But this is going to be the line y equals -13.3. Where that line intersects the graph of g of x. Well, you have a point right here it is. And we can sketch a vertical line through that point. It looks like it's pretty much halfway between the 15 and the 15 and a half line, where I've got it drawn. Of course, it's going to be an estimate, it's not going to be exact. We're going to check it with the equation shortly. But this is then x equals, okay, what's halfway between 15 and 15 and a half? That would be 15 and a quarter. Now, hopefully you can read that. It says 15 and a quarter. Maybe a little bit hard to see that this is a 5, not a 3. But we know from where it is, it's between 15 and 15 and a half. Okay, so from here for a table, over here I'm going to say if x is 13.3, if x is approximately equal, use a wave equal signs at 15 and a quarter. That's our solution to the equation g of x equals 13.3. Okay. Now we also want to find g of 14.7. What does that mean? Well, it means x has been replaced by 14.7. So 14.7 is an x, just like the negative 13.3 is a g of x, which means it's a y. This is an x. So 14.7, well, 14 is here, 15 is here, 14.7 is between 14 and 15, now somewhat closer to 15. We'll do this. We'll call this line x equals 14.7. And now we just want to estimate y. Well, where does this line intersect the graph? It intersects here. So what's the y value? Well, we can do a horizontal line here. And you see the advantage of having these things labeled. You can see that this horizontal line is between y equals negative 13 and, of course, y equals negative 12, but it's better than that. It's between y equals 13 and y equals negative 12 and a half. And it's closer to negative 13. So if this is negative 12 and a half, and this is negative 13, well, you might go to decimals here. Okay, fractions work fine for these numbers. The decimals, okay, this is 12.5, this is negative 12.5, this is negative 13. That looks like about negative 12.8. Okay, so I'm going to say that's about y equals negative 12.8. Quite a bit closer to negative 13 than it is to negative 12.5. And you hopefully have enough number sense to understand that. If you don't, we're trying to develop it because number sense is important and people have lost it by using overuse of calculators, especially in K through 12. Okay. Things have been gained if they're done right, but you know, number sense is it's kind of been lost. So you want to work on developing it because it is important for understanding recalculus and calculus, and statistics, and all kinds of other stuff. Okay. So anyhow, end of digression, y equals negative 12. I'm going to go with 0.8. That's 12.7 would be closer to 12.5 than it is 13. Of course, it's negative, and it might be difficult to see that's 12. Maybe that makes it a little clearer. Okay, y equals negative 12.8. So we say then that g of 14.7 is approximately equal to negative 12.8. Again, let's make sure. Let's see. It should be in the line x equals 14.7 and the line y equals negative 12.8. This is the line x equals 14.7. That's going to be closer to 15 than 14, so it'll be something like this. And negative 12.8, y equals negative 12.8. That's between negative 12 and a half and negative 13. 12.8 looks just about right. Now, this is a hand-drawn graph. A hand-drawn graph is not exact. Yours might be better than mine if you're halfway careful with it. And it's on test, so, be somewhat careful, but don't take too long to do this. You should be able to put down one of these graphs, a fairly accurate graph in a couple of minutes with the label and everything. Takes you 10 minutes to do that. Well, you're going to be in the test instead of a while. So be prepared for that. But I would practice this to do these graphs quickly. Save your time on the test and keep your mind clear for other problems. Okay. So we're doing pretty well here. Now, next question is find the average rate of change of y with respect to x between on the interval 17.1, 17.5. What does that mean? Well, that means an interval of the x-axis. So, do this better prominently. We're 17.5. Now, these are x coordinates. That should be clear from open math and everything else. When you say on the interval 17.1, 17.5, that means on the interval of the independent variable. That means on an interval of your x, if it's a y versus x graph. Okay, so x equals 17.5. Well, that's going to be right halfway between 17 and 18. And x equals 17.1. It's going to be over here real close to the x equals 17 line. Here's the interval. Closed dots and a line between them. And these are going to be kind of small intervals. Just because of all the other stuff that's been labeled. Okay. But now we want to find the average rate of change. What's the average rate of change? Well, the average rate of change is changing y or changing x. Out. So that I should have said between. Let's get the right word in there. Oh, I got all words not really want to right now, but I think they're important. If they're going to be important to you. It's the delta y over delta x between the x equals 17.1 and x equals 17.5 points. I'll even say of the curve. Be very explicit. Okay, well, where's the x equals 17.1 point of the curve? It's where the x equals 17.1 line intersects the curve. That's going to be about here, just below the x equals negative 11 or the y equals negative 11 line. And x equals 17.5. The x equals 17.5 point is right here. Okay. Now there are a couple of lines that we could label. And I'm going to attempt to do that. It might turn out to be a little hard to read. It might even be a little hard to see these dotted lines. Here's a dotted line just below y equals negative 11. Now this is between negative 11 and negative 11.5. So I'm going to say this is about negative 11 point. Okay. That's an approximately equal. And you want to label that. Show me you know what you're doing. If you don't document it and you just write down numbers, then the numbers had better be pretty good. Okay, and really, if you are prepared for the test, you're going to know how to calculate those numbers. So I don't want calculated numbers. I want estimates, and I want to see the estimates. I want you to own these graphs. You don't own the graphs if you shortcut the process of constructing the picture. And the pictures, I assume the picture is extremely important. Okay, so now I can draw a line, dotted line. Here, it's between y equals negative 11 and a half and y equals negative 11. And that looks like between negative 11 point, I think it's about negative 11.3. Okay, so y is approximately, way to keep the sun didn't come out. Doc doesn't know it's okay, but it's in my head. So we've got these points. The points are x equals negative 17, y equals negative 11. 11.1. And 17.5, negative 11.3. Negative 17.5. Not negative 17. 17. Seen all kinds of things that aren't there. But these are positive, obviously. Your exporter here is 16, you go from 14 to 18, you don't have any negatives. 17.5, negative 11.3. Okay. Well, now I think I'm going to move forward a little bit to the right. So okay, you still see all the work. I'm going to over here. I recommend that you do it too. I'm not going to be able to use different colors. Actually, take different colored pens and stuff. Well, too. But you don't really need it. I'll know what I'm looking at, so I don't need highlights. See, if you think you would like to have the highlights to see, take a couple of different colors. That's perfectly legal. Nobody's going to take those colored pens away from you. You don't have a rolled up scroll inside of one of them with all the answers. It's a pretty long scroll because you got to know the process. I don't want to see just the answer. I have to see the process. I have to see these details. Okay, so those are your points. Now I'm going to draw just 2 points here. Represent those 2 points. This point is 17, negative 11.1. This point is 17.5, negative 11.3. Draw a straight line between these points. I can construct the product we've seen. Call it the fundamental product. And I can say, okay, let's see. Here to here, what's the run? What's the difference in the horizontal coordinates? Well, the horizontal coordinates are 17 and 17.5. Doesn't it hurt? Go ahead and draw your vertical lines. X equals 17. X equals 17.5. In fact, I kind of recommend it so you just really reinforce the meanings of these aspects of the coordinate plane and the functions. You want to understand them as deeply as you can because you've got to get into analysis of specific functions very short. Okay, so you could also label the y's. Negative 11.3, negative 11.1 here. Okay, well, the numbers are pretty simple. You can see what the run is. That's the length of the horizontal line. That's the distance between these 2 vertical lines because these 2 vertical lines, at any point, the distance between these vertical lines is the same as the distance between the vertical lines here, which is the run. Another thing you want to do, just to be careful, is you want to put arrows in this. A path that goes from left to right to this point. Okay? And same. Okay? So we're going from left to right. We can follow this path. We start here, we end here. If we follow this path, we start here and end. But that's been a point of confusion. That was initially a point of confusion. I think we kind of reconciled that. Make sure. Okay, so from 17 to 17.5. What's the distance? Well, it's pretty obviously 0.5, but sometimes you need to calculate it. So we write run equals 17.5 minus 17 equals 0.5. We have positive 0.5 here. Now that's what we always do, is we subtract where we are from where we're going. It's where we're going minus where we are. If we do where we're going minus where we are, we get 17.5 minus 17, which is 0.5, which is positive, which it has to be in this case. If you wrote it wrong, if you wrote, like, if this is x1 and this is x2, you do x2 minus x1. You don't do x1 minus x2. If you did, you'd have 17 minus 17.5 equals negative 0.5. Don't do that. Okay, and understand that. It's real important to get those directions correct. And then you got a rise here. And that's where you're going, where you start. Now, it's real easy to look at these numbers. Well, it's 0.2. 11.1 to 11.3 is 0.2. Well, yeah, but you're going from negative 11.1 to negative 11.3. You're going more in the negative direction. So it's going to be downward. Your rise is going to be negative. And to be really sure of that, you write out. Now, you should first think, if you think maybe it's 0.2, maybe you notice that it is negative 0.2, and you reason that out. But then just test yourself, you write out where I'm going minus where I am. Negative 11.3 minus negative 11.1 equals negative 0.2. And I could put a 0 in front of that 0.5, welcome back. Lots of textbooks like to do that. There's good reason for it. I was born before people started doing this consistently, but it was nice on my college years, probably my high school years, back in, a couple centuries ago. Okay, so anyhow, we have the rise and the run, and of course the run is your change in the x coordinate. Okay, that's a delta x. And the rise, which is your delta y, is negative 0.02. Okay. Now I ask for the rate of change. Well, it's the average again, I'll use a capital ROC for rate of change to get it down quicker and stuff that's workspace. Average rate of change of y with respect to x on the interval 17.1, 17.5 is change in y over delta x, which is negative 0.2 over 0.5. And you can calculate that. You should be able to calculate that in your head. But if your head's been replaced by your fingers on a calculator, you might have to use a calculator or do a long division or whatever. You should be able to do it in any of those ways, but it's going to be negative 0.4. And then you can notice that's the average rate of change. And that coincides with rise over runs. That's also delta y over x, which is the average slope. So the average slope represents the average rate of change. That's an important statement. I'm going to write it down. You want to lock that in. And again, that's also something that would be good to write down very quickly when you take the test. One of those little feathers in your cap that you don't really need to answer the question. You get full credit without writing it out. But if you write it out, it might cover some minor error that you made on this problem. And sometimes even on another problem that involves rate of change. Average slope represents average rate of change. Now, I should really say average slope on an interval represents the average rate of change on that interval. Don't have room to write all that out. The idea is very simple. The average slope here, which is the slope of this line, represents the average rate of change. Now, if you're labeling up here, you would put 0.4 here. Negative 0.4. I'll have what I do that box. Go to beautiful 0.4. And I've got to change it, make the box bigger because I need a negative sign. Okay. A box around a number on a hypotenuse with the convention that we're using in this course. And it's not a universal convention, so don't carry it on into your calculus course. By the time you do your calculus course, you should understand it very well, although you can use it in your notes and stuff like that if you wish. But it represents slope. And a slope represents an average rate of change. So there we have it. Okay, so that takes care of the rate of change. And over here on your graph, you probably want to go ahead and draw that triangle. Show that you know that the slope of that triangle is what it is. You probably won't have room to label it, although if your graph is big enough, you could put a 0.4 with a box, negative 0.4 with a box around it here. And then just a glance at your graph would tell you, okay, right here, the slope is approximately negative 0.4. Well, that's no big deal. Just make sure we're still recording. I've been going on for a while. Okay. Now, what else do we have? Well, now we want to express the g of x equals f of x minus h plus k expression for g of x. And that's going to give us a formula that we can use to test our solutions and our estimates. And that's closes up the loop on this entire concept and gives you a much more solid concept of what functions mean and how we analyze and what all the numbers. Okay, so first of all, you have to know, of course, the formula for the negative reciprocal functions. So formula for your toolkit function, graph function. Is f of x minus h plus k. Change the coordinates a red dot. So U of X equals F of X minus H. If you replace X by X minus H, you got to replace this X by X minus H. So that's 1 over X minus H. Now don't try to do the whole U of F of X minus H plus K in one step unless you're very, very comfortable with it. Some of you might well be. It's still safer to do it in 2 steps. And I wrote down what I wanted to write down. Maybe it's dangerous to do it in 2 steps if you do something stupid. Feel free to cross things out. So, and I'm going to write this. Stay there and not try to escape. Okay. I wrote a few of X. I want to write F of X minus H. F of X minus H. Whereas F of X minus H is F of X, but we replaced X by X minus H. So this X is replaced by X minus H. So that's what I wrote down before, but I'd identified that as G of X, which is a bad idea. Okay, you're trying to build up G of X equals F of X minus H plus K. So what do we do next? Well, G of X is F of X minus H plus K. G of X is 1 over X minus H. K is just K. Then specifically, G of X is 1 over X minus H. Remember, HK in quarter to the red dot. If the red dot X equals 16, that was given to you at the very beginning. Oh, so you got an X minus 16 plus K, which is negative. Look at the graph to make sure 12. And you see, it's much easier to look at the graph because you know where to find these things than it is to look back at the instructions and remember what H and K were. You can do it either way, but the graph is a very handy representation of everything that we need. Okay, and the graph is, it's still visible. Okay. Okay, and of course, this would be 1 over X minus 16 minus 12, because plus negative 12 is a minus 12. I don't have room to write that, but I'm going to write it over here. All right, now we have a couple more questions to answer. The next question is, we want to calculate G of X equals F of X minus H for every vertical construction line and make a table. Now there's more to it. I didn't write out all the steps here. After we do that, we're going to calculate for the X value of every point that we use. Well, for the X value of and then we compare them. So the instructions on the test are a little more explicit than this, and presumably you're following along and comparing the instructions on the test with what I'm doing here, so you understand what you need to be able to do. And remember that this is all stuff that I assigned 3 weeks ago. Okay, so it should be a review. What you're saying here. If it's not a review, hopefully it's a clarification that allow you to do these problems perfectly, which is what we're really after. We're going to try to achieve perfection on this because it's very attainable. And it's kind of a big deal if you can do this perfectly. It'll equip you well, I think, for the rest of the course and be very advantageous to you as you study more mathematics, if that's in your future. Okay, so we're about out of room, but we're going to go ahead and make a table. I'm going to go a little bit extreme with my labeling. I want to remind us of everything. Y is g of x, which is f of x minus h plus k, which in this case is 1 over x minus 16 plus the negative 12, so it'd be minus 12. So that's the thing we're going to look at. 16 look like it's 16 and not 10. Yeah, that looks like smudge, but you understand what it is. Okay, we're going to make a table for every one of our construction lines, for the x corresponding to every construction line, which means 14, 15, 15 and a half, 16 and a half, 17, 18. Well, if we put in x equals 14, then what's x minus 16? 14 minus 16 is negative 1/2. And you do negative 1/2 and minus 12, you get negative 12 and a half. I'm not going to write that out, but you should. Just write out what you get when x is negative 14. You're going to do the subtraction. And you're going to get negative 2. Sorry, it's not negative 14, it's 14. 14 minus 16 gives you the negative 2. That makes this into negative 1/2, and add that to negative 12. You don't write that out just to reinforce it. Again, I urge you to write everything out. It reinforces things and replaces hours of review. You probably don't need to review very much if you've written everything out to the extent that you really understand it. Every time you write it out, you reinforce something important. Okay, so we have negative 12 and a half. Now, if x is 15, 15 minus 16 is what? Yeah, it's negative 1. And 1 over negative 1 is what? Yeah, right, it's negative 1. And negative 1 minus 12 is negative 13. And you should be able to think that through in your head. Now you write it out and then think it and understand why it's so. Okay, it sort of makes sense. If it doesn't, at least be able to calculate it. Okay, if x is 15 and a half, 15 and a half minus 16 is negative 1/2. The reciprocal of, so you have the reciprocal of negative 1/2, which is negative 2. Negative 2 minus 12 is negative 14. X is 16 and a half, then x minus 16 is a positive 1/2. Reciprocal of a positive 1/2 is a positive 2. And if you add 2 to negative 12, you get negative 10. Now, I won't go through the details. 17 is going to give you 1 over 1, which is 1 minus 12, which is negative 11. 18 minus 16 is going to give you negative. I'm going to give you positive 2, gives you 1/2. You're going to get 1/2 minus 12 is negative 11 and a half. Really, it's also need to be able to visualize these numbers in terms of the picture and everything else. But you notice that the graphs agree. Okay. Now, you can make your estimates here and then pretend you've calculated. Well, I want to see the details of the calculation. So I want you to write out, for example, x equals negative 14. Q of x equals what? 1 over negative 14. And x could be negative 14. X is 14. You put negative signs where they don't go. 14 minus 16 minus 12 equals 1 over negative 2 minus 12, which is negative 1/2 minus 12, which is negative 12 and 1/2. I want to see the details of the calculation written out. You're welcome to use a calculator. You'll have one available. They confirm your results, that show me the steps and show me that you understand the rules that you're going to need even more than you do here when we get to rational functions in about a month. Okay? Actually, it's going to be less than a month, just a few weeks. You're going to really need these rules. So you want to reinforce it. We're trying to lay the basis for everything that you're going to do in the rest of the course. And it should make the rest of the course much, much easier if you completely master this. If you can do this to perfection for this function, for an exponential function, for a squaring function. Okay? Now we're going to have other functions. We're going to introduce other functions. You've already seen them, but you've seen them in a context where they say punch these buttons in your calculator, and this is what the graph looks like. You don't own that. You semi understand it, but you don't own it. You don't know it to perfection. And if you get these to perfection, it's easy to get the other ones to perfection. And in the process, get a real feel for the coordinate plane, for the meanings of these things, meaning of the group function when you give an x, or the solution of that function equal to some y value, which is a solution of an equation that will also do algebraically. Okay? Gives you a picture of everything, not everything, but of many of the most important things, probably the majority of the most important things that you need to carry out in this course. All right, now, the last thing is, we'll have to put it here, x value for every point we've used. What points have we used for every x value that we've used? Well, we've got them labeled here. Okay. That's 14.7, y equals g of 14.7 equals 1 over 14.7 minus 16 minus 12. That's 1 over negative 1.3 minus 12. Now, what's the reciprocal of 1.3? It's about I'm just estimating because 7 times 13 is 91, 8 times 13 is 104. So actually, I'm going to call that 77. Punch it into your calculator, and it's totally appropriate to punch this into your calculator. You don't have to show me that you can do a long division of 1.3 into 1, although you should be able to if I asked you to, but I'm not going to this fast. Calculator is pretty much appropriate for this. Okay, so that would be negative 12.77. Okay, now let's compare that with what we got here. Okay, we got negative 12.8. The next is negative 14.7. The point of intersection is here. And we estimated the y coordinate to be negative 12.8. I didn't know what that coordinate was going to be. And I didn't draw a great graph. Even with kind of a rough graph, I got an estimate that agrees very well with what you calculated. So we say, a little hard to find a place to down. I'm tempted to get another board. But I'll just kind of write it in bold here. You probably want to put it in the table. I'll put it this way, 14.7, G of 14.7, that's what we just did, is 14.7 I'm always optimistic about my ability to squeeze something into the edge of the board, and I should, obviously, because I'm always doing this. Okay, again. That's equal to 2 decimal places. Here our estimate. -14.7, -12.8. Our estimate is good, down to the 10th. Now with a graph this crude and this small, I can't always rely on having accuracy to plus or minus a tenth. But it seems to have happened here. Let's see how it works out with the rest of the points. Okay, well, I'm just going to write down the conclusions here now. Other comparisons. Other x values that we use to estimate values of the graph, or x values that correspond to values in the graph. X equals 15 1/4 was set to give us -13.3. Okay, give us y equals -13.3. Now we don't have the question there was solve the equation. G of x equals -13.3. Well, we did, and we found that x was about 15 1/4. Okay, so we can test that to verify. So 15 1/4, G of 15 1/4 equals what? Well, your denominator is going to be x minus 16. 15 1/4 minus 16 is -3/4. So it's going to be 1/3/4, which is 4/3. For the fraction. And it's -4/3. So we're going to get -13 1/3. -13.3 repeating. Okay. That's pretty darn close. Now I wrote out the calculation. Okay. So this is a good solution. The target of G of x equals -13.3. We've done good. Now, other x values we need to consider, well, 17.1 and 17.3, 17.4, what was it? 17.5, 17.1 and 17.5. Right there it is in my graph. Again, very handy to have the graph. I don't have to go back and look at stuff. I got everything right there on the graph. Make a big graph with everything you need on it. Okay, so we can compare these estimates, which probably aren't going to be overly great, but maybe we're on a roll here. Interval. View 17.1. I really want you to write down the calculation like this. Point 0.9 minus 12. At this point, you plug that in. 1 over 0.9 is about 1.11. And 1.11 minus 12 is negative 10.9. So the estimate wasn't great. The estimate was 17.1, negative 11.1. So my lines probably weren't all that good. This line is a little closer to this one, but okay. My y equals negative 11.5 line and my y equals negative 11 line are a little closer than they should be. This line is a little closer to this one than it is to this. That line should have been a little lower. Not sure that would have made a huge difference. And actually, I don't see how that could be negative 10.9. Oh, okay. No, I screwed up my calculation. I went one step too far. I did the reciprocal of what I was going to get here. 17.1 minus 16 is not 0.9. It's 1.1. And 1.1 minus 12 is negative 11.1, which is exactly what we estimated. And of course, this calculation, 1 over 1.1 is very close to 0.9. There's no doubt that this is negative 11.1 to a single decimal place. Now it's actually negative 0.9090909. It's 11.11. And there's more. I repeat, you can check that out. Okay. G of 17. I'm on a roll here. Seems that I've nailed everything. And I didn't calculate these in advance. I just took what was in version 4 and I'm working it. Okay. So I expect you to be able to make a bigger graph, somewhat more accurate than what I have. And my reasoning why this had to be less than negative 11 is because the curve had passed the y value of negative 11 and it's going down. It could not have been negative 10.9. That caused me to go back and check an error that I wasn't too surprised to have made, but it just couldn't be. Because the direction of the graph, the point that will pass, the point where y equals negative 11 means you got to be below negative 11, not above. Okay, anyhow, let's put 17.5. Well, your denominator is going to be 0.5. Reciprocal is going to be 2. You're going to have 2 minus 12. And, oh, wait, no, sorry, it's 11.3. Okay, so you're going to have 0.7, reciprocal 0.7 minus 12. Now you want to write it out. So you fill in the dots. Reciprocal of 0.7 is about 1.4. That's negative 11 point. Something's wrong. I don't know. Negative 11.6. Now, I'm pretty sure of that, but you can check it with your calculator. Do 17.3 minus 16, you get 1.3. Okay, never mind. Oh, it's 1.3. And their reciprocal 1.3 is 1.4. So I did something dumb there. Again, negative 11.6 is too far off. Negative 11.3. I think my graph and my estimate were more accurate than that. Okay, well, reciprocal of 1.3 is about 8.7. Oh, come on now. Reciprocal of 1.3 is about 0.77. 0.78. Okay, so if I subtract that, I get about negative 11.2, not negative 11.3. Now you check it out with your calculator. I kind of believe this. I kind of believe I'm off by a tenth here. So my rate of change calculation is going to be off, isn't it? Okay, so the rate of change the interval 17.1, 17.5. That would be 11.22 if I did my arithmetic right. And then here's my delta y over delta x, which I calculated in detail over here. I got negative 2 over, my delta x is not 0.5, is it? Oh boy. I'm glad I discovered that error. And from 17.1 to 17.5 is 0.4. Gives me a slope of negative 0.5. So I should have put a 0.5 up here. Now these little errors that I've made are really easy errors to make. If you're showing me the details of how you get these things, like your delta x is 17.5 minus 17.1. And I did 17.5 minus 17. And that's the source of the error. Now, if you accidentally wrote this down, I might not even penalize it, especially if you've done a couple of extra things and done really well on everything else. I'll probably give you the benefit of the doubt on that. At the most, I penalize a point because there's a lot of stuff in this problem. And a little error like that, that still looks about right as far as the picture is concerned, is more or less forgivable. A couple little errors like that probably would cost you more than a point. And if you've done some extra stuff, like written down some of these things that I suggested, it can be helpful. Okay, so there we have it. So that when we come back down here, we calculate the actual rate of change to find it's not going to be that close to the rate of change that we got from our estimate, which is negative 0.5. If we complete this calculation, we get negative 0.11 over 0.4, which equals negative 0.275. Okay. That's the average rate of change, negative 0.5. Write the delta y over delta x equals sign here. Now I could make a table comparing. And I kind of recommend you do this because after you get all these numbers and document them all, easily put them in a table. There aren't that many of them. So got x equals 17.1. I persist in writing this as 17. Should be 17.1, negative 11.1. Okay. So we have calculated y and the estimated y. And it turns out that the calculated y and the estimated y were the same. We had x equals 17.5, calculated negative 11.3, estimated negative 11.3. And this is 11.11, I think this is 11.3. Correct that if you wish. 14.7 gave us negative 12.8. Our estimate is negative 12.8. Now you can calculate this, calculate these numbers to a couple of significant figures. Okay. So you can really see that they aren't exactly what these numbers are, but they're very close. Okay, then we have there somewhere. What was the numbers? Look back here. we had to calculate one for 15 1/4. And 15 1/4. Where is it? Should have been more organized. Well, 15 1/4, our estimate. I'm gonna go by memory, was -13.3. And our result, I think, is -13.33. Put a question mark. Can't immediately find it, which is a. Oh, there it is. Okay. So we did the estimate here, 15 1/4. Gives us this, the target was -13.3, so. A calculation to two significant figures, -13.3. Now the one that. Didn't come out exactly, I think I may be missing it. Our calculated y for x equals 17. For x equals 17.5 was, or we calculated, although I can easily not do it again. I'm gonna pause for a second until I find it. I want you to have to. 6 time I had to pause here, I'm going. Okay, the price I pay for doing things in my head, and sometimes I write them down wrong. And if x equals 17.5, you put a 17.5 here minus 16, you get a 1.5, a 3/2 in the denominator. Reciprocal of that's 2/3, so it'd be 2/3 minus 12, which would be 11, and a third, which is 11.33. Now, 17 1/4, I have says 15.33, and we estimated -11.3. So actually our estimate was real good here. That affects the calculation of the rate of change. Double check all my numbers here. I've made a couple of mistakes. Be 11.33 minus this. Now, I wasn't at all surprised to be this far off on the rate of change. Okay, get a -2.75, we should have had a -0.5. Just because of inaccuracies in the graph, but it turns out that my estimates actually work out pretty well. And this numerator then becomes 0.22 over 0.4. And that gives us 0.55, which compares well with the -0.5 that we estimated. So that gives us confidence both in our estimate and in our result. Here's the last comparison. We can compare the average rate of change calculated, estimated, and based on our estimates. We didn't directly estimate the rate of change. We estimated the points that give us the rate of change so that we could draw the triangle and so forth. Well, that would be a complete solution. Okay. Now you're going to have two problems of this nature. Okay. If you do a really good complete solution on one of them, and then write out a little less on the other one, but get your solutions and make a table of your comparisons and give me some documentation as to how you did that. I'm going to be fine with that. You got a good complete solution on one of them, and show me the results of a good complete solution with some of the steps on the other one. I'll be pretty forgiving on little errors on the other one. Okay, and I'm pretty forgiving of small errors but you've got a calculator in your hands. You do it carefully. Your estimates should reconcile well with your calculations. And if they don't, I at least want you to point out, dang, that estimate was way off. And that was an estimate I used to get my average rate of change, and that made it way off, but I don't know what I did wrong. And, you know, I'm on the verge of starvation. I'm only doing my first problem. I better move on and do some more problems. And I can respect that. I'd probably penalize you just a little bit. I'd penalize you a whole lot less if you acknowledge that your calculation is off and at least indicate that you would like to make an attempt to figure out why it was off, but you've got to move on. And hopefully you can come back. Okay. And if you do have time at the end, come back and see if you can fix it. I'll penalize that a lot less than if you just put them down and don't notice that they don't agree with them. So we want to acknowledge that some of these estimates are way off of what we calculate, and then at least try to look back and fix our estimate or fix our calculation. You know, so that's kind of what I'm looking for. Primarily, if you've got a really good picture with labels of all your construction lines and everything, okay, on a 10-point problem, that's going to be at least 6 points out of 10. The rest of this stuff is the extra 4 points. Now, 6 points out of 10 is like low D. Okay. And really want the perfection. I want you to get 100% or close to it, as close to it as you possibly can. When you get into the A range on this problem, and hopefully the rest of your problems will also be in the 90% range, 9 out of 10, or better, and that would be an A. I think everybody is capable of making an A. I hope you have time to do what's necessary to make an A. And I hope you watch all this video because there's a lot of stuff I said here that should be helpful to you. This video is kind of in place with the class that we missed today due to the flooding. And that, you know, flooding was, I think, a perfectly good call because we had a huge amount of rain in the last several days. I'm estimating 7 inches at the house. And I don't remember what all the amounts were up to last night, but last night we got 4.5 inches. And we had well over a couple of inches before that. And the hurricane remnants haven't even gotten here yet. So no quarrel with the call on the flooding. Some people can come to class and then not be able to get home. I don't want that to happen. Okay. Now, if there's no rain today, no rain going to be today, then people, I think, in my opinion, if I was making the decision, I'm not questioning what decision other people make because they're kind of constrained to make a conservative decision for legal liability reasons and so on. But if there's no rain forecast for today, it's clear that there is very little chance of significant additional rainfall and additional flooding. Then I would think people could make intelligent decisions about whether to come or not. You could comment with that. So there's all kinds of ifs and buts. But with that amount of rain, even if it was sunny and bright for the rest of the day, I still think maybe this class today is a small price to pay for what it could have. Okay, so I totally agree with the decision for the day, no matter what. Okay, and if I disagree, it's a respectful disagreement. I know I don't want to be on the seat of the person who has to make these decisions. And I agree with making conservative decisions. And I'm not talking politically conservative, I'm talking legally conservative. We'll all protect ourselves from liability within reasonable bounds. Okay, that's a mathematical decision, which is why I kind of go on talking about it a little bit. What's the probability of this? What's the probability of that? What's the cost of this? What's the cost of that? Learning to do this kind of stuff helps you make analogous decisions in your life and maybe in your career. Okay. Very good. Hope this has been helpful. It's kind of a long video, but I hope it's worth the time you take to view it.